Okay, so what I've done so far is just explained the numbers that you see if you look ahead to chapter 32 and how they translate into the graphs that we're familiar with our production possibilities curves. That's what we've done so far, that's all. Okay, now in chapter 2, I know people watching this are primarily focused on right now, we have these terms absolute advantage and comparative advantage. In this segment I'm going to explain those terms with this here because in front of us, because it makes more sense like that. So, absolute advantage. Absolute advantage is the advantage held by the party that can make more of the good or service in a given time period. Absolute advantage is held by the party that can make more of the good or service in a given time period. Absolute advantage gets in the way in understanding the gains for trade because if you look just at absolute advantage, it makes it look like trading is silly, a bad idea, bad deal. So let's explore this. Let's make sure we're seeing it. Let me ask the question, you give it a thought. Who has the absolute advantage in the production of apples? Who can make more apples in a given time period? Well, if Ron devoted all of his time, energy, and resources into making apples, he could make 60. If Sam devoted all of his time, resources, and energy into making apples, Sam could make 90. So I'm going to put a red triangle around it. So I thought I was going to put a red triangle around it. This red triangle. Yes. I'm going to put a red triangle around it because triangle looks like an A for absolute advantage. So right there, the fact that Sam can make 90 apples tells us that he has absolute advantage in the production of apples. How about sausages? Use the same logic and see if you can see who has absolute advantage in the production of sausages. Well, in a given time period, Sam can make 30 sausages. But Ron can only make 15. Sam has absolute advantage in the production of sausages also. So this is what I mean. I think maybe you see what I mean when I say absolute advantage gets in the way in understanding the gains from trade, because when we look at this, we'd say, look, Sam's just better at producing both. There's no reason for Sam to want to trade because he'll be made worse off. You can't be made better off by doing this, by engaging in trade with Ron. But that's not so, and we'll show that in the later video segment or segments. We'll show that quite the opposite. But first, let's explore this term, comparative advantage. Comparative advantage is held by the party who has the lower opportunity cost in the production of a good. Put differently, comparative advantage is held by the party who gives up less to make a good than the other party gives up to make the same good. Okay, usually I would repeat that in person, but just back up if you didn't follow it. I think I said it clearly and right. Pretty sure I can get my tongue twisted on that. So what that means is we need the opportunity cost for each person to produce each good. The opportunity cost is what they give up of the other thing, right? Remember in the previous video I talked about how Ron could make more apples if he gave up sausages. So what we need to explore is how many sausages does Ron give up to make an apple? That will be Ron's opportunity cost. And I'm going to put that in green if this green marker will allow it. If not, I'll try to find one that does. So there are a number of ways to approach this. I just usually approach it from the endpoints and sort of just figure it out. But there are different ways, and I'll show you some different ways we can go about this. If Ron could produce 60 apples by producing no sausages, if he gave up all 60 apples to produce 15 sausages, how many apples does he give up for each sausage that he produces? He gives up 60 and gets 15. For each of these that he produced, how many did he give up? Well, if you give up 60 of something and get 15 of something else, You gave up 4 for every 1 you got. So a sausage costs him, that marker is indeed dead. It's a new semester, and I'm breaking into my markers. Each sausage cost him 4 apples, and I would label it. And I left space there to squeeze it in. I would label it first time around. If not, you'll forget what you just took the time to figure out. Now, if he gives up 15 sausages, suppose he wasn't making any apples, he gives up 15 sausages, and doing so, he can get 60 apples. Does he give up a whole sausage for each apple? He gives up something less than a whole sausage for each apple. In fact, what he gives up is 1/4 of a sausage for each apple that he gets. I know that right there isn't very clear. Let me write it down and then explain it. And then, as I said, I'll explain other ways to look at this. 1/4 of a, it's not really plural, is it? Of a sausage to make an apple. An apple costs him 1/4 of a sausage. What's the relationship between 4 and 1/4? Just in math. They are reciprocals. And that is a very handy thing for us, because seeing the trade-off that is less than 1, I find challenging. But if I can see the one that's greater than 1, one of those mosquitoes is after me now, as discussed in a prior video. If I can see the trade-off greater than 1, and notice it's reciprocal, the other thing is I'm home free. Now, another way to approach this, or what I used to do when I was an undergrad when I first did this, was because I didn't want to get things wrong, a way to check this is to just do a simple little doodle. Let me do that with this one though, because it's an easier doodle, and you can use it to reinforce what you have going there. Let's try the same thing, same exercise over here with Sam. We're looking for Sam's opportunity costs. All right. Now, if he gave up, start with the bigger of the two numbers that he can produce. This is the 90, which I never labeled. That's his 90 out here on his PPC. That's the 90 here. If he gives up 90 apples to make 30 sausages, how many apples did he give up for each sausage that he got? He gave up 90, he got 30. For each one that he got, how many did he give up? Each sausage cost him 3 apples. If he gives up 30 sausages to get 90 apples, for each one that he got, did he give up a whole one of these? He gave up less than 1. Another way we could think about this is if I struck out the zeros for just a second. If you gave up 3 of something to get 9, for each one you got, you didn't give up a whole one. You gave up 1/3 of one. And again, what's the relationship between 3 and 1/3? These numbers are reciprocals. So I said I would show you another way to check your work to make sure you're getting this right. And let's do that now. If I think of sausages, cooked sausages, I think the brown. So if I draw one sausage for each of my one apple for each of my 10s of apples, or one sausage for each of my 10s of sausages. There's a sausage. Clearly that's a sausage. It's brown, cylindrical. That's obviously it's a sausage, right? But he can make 30 sausages if he makes no apples. So that's 1 for each of these 10. I put a line through with my fingers, I put a line through my 0. That's it. Everybody see what I'm saying? 1 sausage for each of the 10 sausages he can make if he makes no apples. Or he could stop making these 30 sausages and make 90 apples. Apples, I prefer red apples. Let's see if this red marker works. If not, I'm going to switch to green apples. Oh, that does. These are clearly apples, right? They're round. They're circles in 3 dimensions. They're balls. These are obviously apples because they're red balls. 3, 6, 7, 8, 9. Now, if you're going to do this exercise, you do need to make sure you count correctly, because if you miscount, you're all messed up. So check and recheck. 3, 6, 9. So there are my 9 apples. That each one represents 10 apples that he can produce. So he can produce 90 apples or 30 sausages. Now, to symmetrically allocate these two goods as they're drawn very artistically, very clearly, this is realism right here. I'm sure you can forward this to your art professors as realism. In order to symmetrically allocate these, there's only one way it can be done, and that is 3 apples for each sausage. 3 apples for each sausage. Each sausage costs 3 apples. This is also handy because a lot of you are looking at this going, he's making this harder than it is. Duh. 90 divided by 30 is 3. Duh. 60 divided by 15 is 4. 15 divided by 60 is 1/4. Duh. You might be thinking that. Well, guess what? 50% of the time, if that's all you know, 50% of the time, you're going to put these in the wrong place. Because it's a coin toss. If you don't understand what giving up something to get something really is, if you only think it's simple division, one number over another, on average, half the time you're going to put them in the wrong place. You have to know what you're giving up for what you're getting. A simple little thing like this will clear that up for you so you can put it in the right place. I do know that 60 divided by 15 is 4. But I didn't explain it that way at first because you need to know where the 4 goes. And if you really want to get sophisticated, you could plot your production possibilities curve and look at the slope of your rate of trade-off. Since we're using straight lines, you could look at the slope of this line. This is going down 1 over 3, but you still have to know where to put that, which I haven't yet to find a student who liked to find opportunity costs by looking at the slope of the line. But it's doable. You could do that. So there are 3 ways to figure this out, really kind of 4. The first way, the way I actually go about it, is to just look at it and say, I'm going from the big number to the small number. How many am I giving up for each one that I'm getting? And that helps me to put it in the right place. Another way you could look at it is with a doodle, where if you have, this one would be harder, because I don't want to draw 15 and 60. I don't actually want to draw that. And this isn't an even number, so it makes it a little harder to lay out so symmetrically like that. I'm sorry, it's not a tens like these are. But once you've done it one way, you can kind of see it the other, right? So you could use that method. You could look at the slope of the line, or you could just divide the big number by the small number and reinforce it somehow or other to make sure you put the opportunity cost where it belongs. So there are a number of ways to approach this. I know they're not easy, but if you have a couple ways to approach it, you just check your work and you can get there. So now, why have I done all this? Because we're defining the term comparative advantage. Comparative advantage belongs to the party who gives up less to make the good. Put differently, if we want to use our 10-cent term, comparative advantage is held by the party who has the lower opportunity costs to make the good. Now that I have 4 opportunity costs listed here, it's not too hard to find those opportunity costs. Comparative advantage starts with a C, so I'm going to circle where comparative advantage is indicated because a circle looks like a C. What's lower, 1/4 or 1/3? That is, what is the lower opportunity cost to produce an apple? 1/4 or 1/3? Which one is lower? Well, this is 0.25, this is 0.33. I'm going to put my circle around a quarter because a quarter is lower than a third. If that was throwing you off, here's everybody's chance to raise your hand in front of your computer to answer this. This isn't a Zoom call. I won't see it. I'm trying to be a little funny. Come on, I'm trying to make a living here. What's lower for the opportunity cost of producing a sausage? 4 or 3? Which number is lower, 4 or 3? That's right, 100% of the people watching this got it correct. 3 is lower than 4. So I'm going to put a circle around that. Now I have identified comparative advantage. Sam has the lower opportunity cost in producing sausages. Ron has the lower opportunity cost in producing apples. Ron has comparative advantage in the production of apples. Sam has the comparative advantage in the production of sausages. And this is true that Ron has the comparative advantage in apples, even though Sam had absolute advantage in the production of apples. He had both absolute advantages, but not both comparative advantages. Ron gives up less to make an apple than Sam does. I'm going to stop again, and then in the next piece, I'm going to show what the value is of all of this, and how, in fact, this is a cliffhanger. You're going to have to tune in next week. Actually, you can just click on the video right after this, and you'll see how important this is, and how using our simple model here, with some assumptions that are in place, which we can discuss, we can show, as it was stated in the 10 principles, that trade can make everyone better off. You just have to tune back in to see.